This is a brief tutorial on Gaussian elimination. So there are a lot of videos online showing you the process of Gaussian elimination, and what I want to do here, rather than repeat that, is just to give a little motivation for and a little understanding of what Gaussian elimination is, and then I'm going to direct you to a video or two online that you can watch to actually see the mechanics. So what I have here is a system of 3 equations and 3 unknowns. And the unknowns, of course, are x, y, and z. And I've chosen this equation, well, for several reasons, but one, it's in a nice form. What's nice about it is that I right away can find z. In fact, we have z. Let me just put it over here. Z is minus 4/3. And once I know z, I can solve for y by writing y is equal to 3 minus 3z, which is 3 minus 3 times minus 4/3. And that would be 3 plus 7, 3 plus 4, which is equal to 7. And then I can use both z and y to solve for x. Here x is equal to 9 minus y minus z. So that's 9 minus 7 minus 4/3. So that would be 2 plus 4/3, or 6/3 plus 4/3, 10/3, if I did my arithmetic correctly. So we have, so then we can write, so we have therefore x is equal to 10/3, y is equal to 7, and z is equal to minus 4/3. And we have solved for our 3 unknowns. Now this happens to be a special case. The 3 equations that are provided here are in what's called an upper triangular form. If we were to rewrite this equation, system of equations, in matrix form, we could write it this way. I'm going to have a matrix that's going to be a 3 by 3. I'm going to write x, y, and z here. And on the right of the equality, I'm going to put 9, 3, minus 4/3. And now we fill in our matrix. So I'm looking for the coefficients in front of each of the x's. In the first row here, call this row 1, row 2, row 3. So we'll repeat that here. We have 1x plus 1y plus 1z. In the second row, we have 0x plus 1y plus 3z. In the third row, we have 0x plus 0y plus 1z. And what we see here is that we have what's supposed to be a upper triangle. I can't seem to draw it right. Okay, so this is upper triangle, right? And so this as a whole, that's ugly. This matrix as a whole is an upper triangular matrix. And the reason we call that upper triangular is because the lower triangle here are all zeros. And when we have it in that form, we actually have solved for z because x and y are not in that last equation. And then we can back substitute to find y, and then back substitute z and y to find x. And so the whole point of Gaussian elimination is that we start with a system of equations that are not in upper triangular form, and we do what's called row operations on the systems of on these equations to convert our original set of equations into an upper triangular matrix. And that's that's the process. As an example, let's suppose that we had a slightly different system. So let's say we had one misplaced non-zero here. We'll say that we have a let's see, a 2 here and a 1. Okay, x, y, z, 9, 3, and minus 4 thirds. Okay, so what we need to do is we need to replace this 2, we need to change that to a 0. So how would we go about doing that? Well, we use either row 1 or row 2 to make the modification to row 3. Now, we want to, so for instance, we could take minus 2 times row 1 plus row 3 and put that into row 3. What will happen there is, if we do that, I'm just going to rewrite the new row 3. We would have minus 2 times 1 plus 0, minus 2 plus 2 is going to be 0, minus 2 times 1 plus 1, so this is minus 2 times 1 plus 1, is going to be minus 1. And then, of course, we do the same thing over on the for this constant. But I won't do that here because we have a problem. What I want to show is that if you choose row 1 and add it to row 3, even though you scale it, we do successfully get rid of the 2 and change it to a 0, but we've undone the 0 that we had here, and we now have a negative 2. So we don't want to use row 1. What we want to use instead is row 2, because row 2 has a 0, a leading 0. So we will do minus 2 row 2 plus row 3 substituted into row 3. So let's do that. So I have 1, 1, 1, x, y, z, 9, and 0, 1, 3, and 3. And now what we have in row 3, we have minus 2 times 1 plus, we have minus 2 times 0 plus 0 is 0. We have minus 2 times 1 is minus 2 plus 2 is 0. And we have minus 2 times 3 is minus 6 plus 1, that's minus 5. And finally, we have minus 2 times 3, minus 4 thirds. So minus 2 times 3, minus 4 thirds. So that's minus 6, or minus 18 thirds, minus 18 thirds minus 4 thirds, so that's minus 22 thirds, if I did that correctly. Okay, and now we have successfully turned this into an upper triangular matrix, and from here we can write z is equal to minus 1/5 times minus 22 thirds, and then we can back substitute to find y and then z. So this is the process that's used to perform Gaussian elimination. And again, the overall purpose is that we want to form an upper triangular matrix with zeros down in the lower triangle, and from that format we can solve for our last variable here, z, and then use back substitution to find y and then x.